Hey everyone. So today we got Alpha and I have some better questions. Hopefully we can have him struggle a little bit through these. So what language are you going to be using?
Oh, let's do Python this time. I'm too tired for the Java.
Let's see.
Probably rusty on Python, so it'll be good.
Yeah, you can never forget the best programming language on earth.
Yeah,
No,
I mean,
I'm just kidding.
at this point, it's basically just like writing a prompt and feeding it into cursors. Basically Python, right? Close enough.
Decide questions.
Dude, we should try that. Like, you find some crazy hard stuff, we try to feed it into the LLM and see if we can get
Yo,
use
there
the AI
there there
assistant.
is some hard ones. Have you seen Advent of Code?
Yeah,
Have you heard of that? Some of those later ones are really hard.
yeah. I think I did last year. I did the first half, and then they had some stupid one with some tree thing, and I was like, okay, what is this even testing? And then I just like quit. But yeah, I think I did the first half, and it
Nice.
definitely got started getting challenging.
Yeah. All
So
right. So we're given an integer n. Return the number of structurally unique BSTs, which has exactly n nodes of unique values from 1 to n.
all right. Uh, okay, so just to define structurally unique, let's see. So I guess we can. Where's the drawing thing in here again? Do they even have it? All I see is the AI. Oh, there it is. Okay, so structurally unique just means they're the same shape or something. Like uh, like yeah, is that correct?
Same structurally unique. Let's see.
Yeah, can you pronounce it?
Yeah, I can't pronounce it.
All right.
Let's go like this.
All right, so
So
so like
that's structurally unique.
yeah, so these two are structurally unique, but if I had it in like this
If you had
way,
one, two, three, and three, basically go back.
oh yeah, okay. Okay, so the are those structurally unique? Or are they
This
the
is not
same?
structurally unique. They're exact same, right? But like this is
Got it.
structurally unique,
Okay, I
right?
think I gotta zoom out or something. Okay, got it, yeah.
This right here is structurally unique.
Alright, got it. So essentially all we care about is the connections, we don't really care about the numbers, so we can just use like the number of nodes we have.
Yeah.
Yeah.
So okay, pretend we have three. Let's just make sure your understanding is correct. What are the
Right,
different structurally unique nodes, and then we can work from there.
right. So there's these two. Then there is this the other way, right? So this would be if this was the left instead.
Or just draw them out, like from here, from n three. Can you draw
Yeah,
each
yeah,
one out
yeah. Okay,
structurally? This we have.
sure, yeah. So one would be like this, right? One would be that. Is there any other one? Yeah, I think there's more actually. So if I had this, that, right?
Yep.
And then the other side. Actually,
You
no,
already
we
have
already
that.
have that one. Yeah, yeah, yeah.
I
Okay,
think
okay.
the other one
Okay.
is just
The right, right?
this
So
guy
it
on
goes
this
right
one.
and then left.
Yeah.
Yeah, okay. So this way. Okay. Let me zoom out here. So what is that, like 5?
Yeah. Answer there is five.
Okay, cool. All right. So I think because we don't care about nodes, basically it just comes down to like ranges. So centrally we can have like I don't know if this is DP or something, but our base case here can be yeah, I can start writing in the thing. Our base case can be if n is 1 or 0, then there's only like one way to do this, right?
Mm-hmm.
Because one node can only be made in one way. Um, and 0 nodes can only be made in one way as well, just like null.
Mm-hmm.
So that is the other one. And then for the other cases, so let's say like n is 2. Um, basically, we have to pick like what node we pick to be the center. and then the rest of it is like a recursion. So if we have 2 nodes, we can either pick like 1 to be the center, and then whatever we pick to be the center, like everything to the right will go in the right subtree. So meaning like if I have like left, root, right? So I can either have like 1 here, and this is 1 node, and there's nothing, or I could do, I could pick the root to be, or I guess, yeah, let's just actually say what node we pick to be the root. So let's say for 2 we have nodes 1 and 2. So this will be like root 2. We could also do it this way, where there's 1 node here and no nodes here, and so on. So basically, for whatever node, so the like I guess the pseudocode would be like pick every number from 1 to n to be the root,
Mm-hmm.
then recursively call left and right,
Mm-hmm.
and then for that root, number of combinations is just left times right, right? Like whatever way we could structure the left side and whatever way we could structure the right side. And we could probably have some caching here because we're gonna have like our DP function, I guess, is only going to take in like 1 number and just calculate this thing. So we can have some caching for sure. So I think we can just do like a top-down DP with a cache, where we essentially break this down. And yeah, our base case, like when we
Just
know,
one.
yeah. So the way we could do this is, yeah, basically like whatever number we pick. So if n is like 5, and we pick the root, like let's say n's 5 and the root is like 3, that means we know there's 2 nodes to the left and 2 nodes to the right. But if we pick like the root to be 4, then there's like 1 node over here, and what was the other one? 3 nodes over here, and so basically just like our deep top-down DP recursion, and we just sum it all up and return that thing. Does that make sense?
So every number pick one to the left, or pick a number and then figure out how many nodes are into the left and nodes into the right.
Exactly. Yeah.
And pretty much, okay, when we get down to like the bottom of the tree, we're gonna be saying the bottom of the recursion. We're just returning like 1.
Yeah. If we have 1 node, it's 1. If we have no nodes, it's 1, because there's only one way to do that. And then everything else is just a recursion.
Let's see. Will that work for like a simple, like try it for 3? For 3.
Sure. So for 3, so our thing for 3 will be, so we pick 1 as the root. So left is 0, so there's only one way to do that. Right has 2 nodes. So for 2 nodes, that's also a recursion. So for 2 nodes, we have to calculate what that is. So right is like n equals 2. So for n equals 2, I think thinking about it, there's 2 ways to do that, right? Yeah, there's 2 ways to do that. So here, there's 2 ways here. Because essentially, you can make a node with a left or a node with a right. So there's 2 ways to do that. So in this case, with 1 as the root, there's 2 combinations. Then we pick 2 as the root. So if we pick 2 as the root, there's 1 node
But
to
do
the
we
left.
cache this? We cache this, or it goes
Yeah,
all
we
the way down?
cache. Yeah, we just cache them all. So
You
that way
say
it's like
right
n
always has 2.
no, I mean like we're gonna have the same calls a bunch. Like if we have like 10 nodes, like as we go down, we're gonna have the same numbers we're gonna call. So that's what we want to cache. But yeah, so
Mm-hmm.
if we pick 2 as the root, there's 1 node to the left, 1 node to the right. So there's only one way to do that for each of those. So this is 1 total. And then if we pick 3 as the root, that's just going to be the reverse case. So left will be 2. And wait, actually, here this is 0, right? If we pick 1 as the root, there's nothing to the left. So this is just the reverse case of the same. So there's 2 here as well. And then 2, 2, 1 is 5. Is that what we had in the picture? I think.
Okay, yeah. So if we pick 1 as the root, and then the left is 0 and the right is 2. Okay.
Mm-hmm. Yeah, I mean, we could show the recursive
Yeah.
case for
Okay.
n
Try it
equals
out.
2, but for...
Try it out.
Okay, yeah, cool. Okay, so let's see. So def, we can call this like count trees or something. N Okay, so we just need a DP function. What the heck? Autocomplete. Don't do it. No. Stop. Enter. Okay. I think this is from here. Okay, and you can definitely do this bottom up as well. But yeah, we'll just do it this way. Okay, so pn. So if n is less than or equal to 1, we'll return 1. Otherwise, so we basically have to go through all of the numbers in here and then make that the root and then count the left and the right. So that will look like this. I in range. I guess to make it easier, we can just one index this. So we could do this. So this is going to be so whatever number we pick is going to be the root. So the number to the left will be, let's see, I minus 1. Number to the right will be n minus I. Yeah, okay. And then we just do a, actually, so this is a little bit wrong. So this is dp, right, of that. dp of that, dp of this. Okay, this is how many numbers we have. And then this is just that. That.
I minus 1, okay.
Yeah, so like if we have 5 nodes and we pick 1 to be the root, then there's 0 on the left. If we pick 2 to be the root, there's 1 on the left.
Yep.
And then the other one should be correct as well. So like if we have 5 nodes and we pick node 5, there's none on the right. If we pick node 4, there's 1. Okay, so basically we just do that. And then we just return dp of whatever that thing is. Yeah, and I think this should work. Can I test it?
Yeah, let me see.
Okay.
I'll test it.
Okay, sure.
Actually, let me just send you an invite.
Oh, to that thing? Okay, sure. Did you put it in the meet or? Okay.
Shoot.
Okay, cool. All right.
Nice, solved it.
Okay, nice.
Okay, we'll move on to the next question.
Definitely refreshing to do Python because it's just like, wow, I just wrote like 5 lines and it worked. It's nice.
Yeah. Okay, we're gonna do a fun one.
Fun for you or fun for me?
Fun because it's more realistic kind of thing.
Okay.
Damn, 10 minutes on that question? Holy crap, I thought that would take you longer.
Yeah, I'm giving myself more room to fail, you know?
So there are n people in a social group labeled from 0 to n minus 1. You are given an array logs where the log timestamp is a timestamp that indicates when xi and yi will be friends. Right. Friendship is symmetric. That means if A is friends with B, then B is friends with A. And it's also transitive. Or there's also acquaintances, right? Person A is acquainted with person B if A is friends with B, or A is friend of someone acquainted to B.
Yeah.
Return the earliest time for which every person becomes acquainted with each other when I give you the logs. So we just need to know the earliest point in time, then people are all...
Okay, got it.
Wait, let's go back to your... Let's go back to your algorithm. Come back to unique binary search tree. I forgot to ask you time and space complexity.
Got it. Yeah. So, let me look in the. Okay, so the DP is n time because we're getting to every point once and solving it, and everything else is cached. So I think this is just. Let me think about that. I don't think that's wait. So we are looping as well. So like, yeah, I don't know if it's actually n or it might be more than n. Yeah, I think it has to be more than n, right? Because like even when we call it the first time, it'll loop. Yeah. Yeah, I feel like it's n squared for time, and then space would be n because we have the loop in here. So
Yeah.
even though that like this is n and this is n, and then yeah, I think that makes sense to me. Does that make sense to you?
Yeah. Okay.
Okay.
Cool. Let's hop back onto this one.
Okay, sure. So there's n people. Okay. Return the earliest time where every person. Okay, got it. Okay, let me just draw. So I have an idea. Let me just make sure it works. So I guess I don't need to draw the circles. I'll just have the people. So there's like 5 people here. So let's just say we have like 0. Zoom in or something. Can I do that?
You
No.
don't like to do like just freeform?
Oh, the circles? I mean, yeah, I
Or
could draw the
just like,
circles. Oh, yeah, I don't know.
like you like to use these like things like this.
The built-ins.
Or, yeah.
I'm trying to use the hotkeys because I'm using this thing for a lot of stuff and a lot of like everyone uses this now. I think it's like the standard. I think learning the hotkeys might be worth
Yeah.
something. I don't know. Okay, so we have like 6 things here. So let me just zoom out of it too. It's also kind of annoying when it's like in a platform because then I can't full screen. Like normally I just have it full screen.
Mm-hmm.
Okay, something like that. We kind of just spread these out. I'm curious if this works. Not 100% sure. Okay, so let's say we have these people now. So this is like what 0 to 5. So 0, 1, 2. Not very. Okay, sure. Okay, so in this example, are these logs in order always?
No.
Okay,
Or
so
in time?
yeah, in time.
Oh, okay. Oh, you're saying is it sorted by time? I
Yeah.
think. Let me check. Yeah, all the values in the timestamp are unique. All the
If they're
pairs.
not, we definitely
Oh,
want to sort by time.
I don't think it's sorted by time. It doesn't say. Wait, let's see.
Okay. In your example, are they? Yeah, I think so.
Let's
Okay,
just
so first
assume
thing,
they are first, and then I
yeah,
think that's a
yeah.
very. I mean, all we need to do is sort.
Yeah, so there's not much there. Okay, so my idea here is use union find, and basically we can just try to connect them, and then when everything's connected, then we return that time. I just want to make sure this works. So with union find, pretty simple. First, everything is its own component. So we have 6 components to start off, and then every time we were able to make a successful connection, that means that these groups weren't connected before, and so that basically connects 2 components into one, and then when there's only one component left, then it's successful. So let me just make sure that works. And if there's like an edge case, so we can say we connect this in the beginning, and so now there's 5 components, and this would work. Let me see here. Can I just write bigger? 5.
Fine.
Okay, yeah. Yeah, I guess. Okay,
Oh, yeah.
so then we connect 3 and 4. That also works, so now there's 4.
Or,
2 and 3 also works, so now there's 3.
but
1
every
and
time we
5
connect
also.
one, we reduce by one.
Yeah. But with union find, if you connect and things are already connected, not directly, but in some way, it doesn't count, which is kind of what we need here. So like, if I have
Yeah.
like lower down, if I have like 1 connected to 2, connected to 3, and I try to do this, this will say invalid, which is what we want because they were already connected. Because we just need to care as long as they're acquainted, right? We don't care about like
Yeah.
directly connected, right? So I think union find is kind of like perfect for this. So yeah, so where was I? 1 and 5. Yeah, so
Yeah.
1 and 5, so we
One and
reduce
five.
another 1. Yeah, so now we have 2 things left. 2 and 4, so 2 and 4 are already connected, so this will be rejected.
Yeah. So if it went like
0
that,
and 3.
we wouldn't reduce the edge count.
Exactly. Yeah. Union find only connects when they're in separate components. So this
How
would
would you
just
know they're in separate
return false.
components? Like what in the algorithm is gonna tell you?
So in union find, everything in a component has a shared parent.
Mm-hmm.
So let's say for this, the shared parent is like 4. When you try to connect 2 points, you get the shared parent, and if it's the same, you just don't do anything. So like
Yeah.
this would
Okay.
return 4, this would return 4,
I
and
see.
yeah, you just wouldn't do anything.
Makes
So
sense.
for 0, 3, that would also be connected, and then yeah. So now that we were able to make n-1 connection successfully, then we're done. We don't even need to keep track of how many components we have. We can just, like, if we know how many people we have, we can just try to make n-1 successful unions, and then that would always reduce it down to 1. In which case, yeah, so that would be that.
Sure.
Mhm.
Yeah.
That would be that, and then we just reduce whatever time that was. Which in this, is that the answer there? The 20190 something? Like on line 14?
Yeah.
Is that the answer for that one?
Yeah. Answer.
Okay, and then as far as not being connected, so if we try to run all the connections and we never get n-1 successful unions, then we can just return -1. So
Okay.
yeah, the step would be like sort and timestamp, and then do that. And yeah, I think that's pretty easy to code and pretty easy to do. So I'm
Mm-hmm.
gonna go with that if that works for you.
Sure.
Okay. All right. So union find. Yeah. And I coded this a bunch, so I can do it pretty quickly, hopefully.
Last time you're like, you didn't do it in a while.
So
You want to do
usually
it on
what
the
I
go.
do with this is, and I think that works for me, is like maybe a third of the time I get this problem, I code it myself, and then the other times I just paste a template because I don't want to have to write it. But
Mm.
it takes like 5 minutes. So union find has a roots and a ranks, and ranks just means like the depth of the component, and so everything's just 1. And roots is like what's that root of the component that I talked about, the top level parent. And here it's just let's see, I for I and range n. So everything is its own root in the beginning.
Mm-hmm.
And then find. So find recursively finds the parent, and then it makes it so the connections are as short as possible. So if self roots x does not equal x, then self roots x equals self find. Yeah. Let me think about this. Yeah, I think it's like this. And then we just return self roots x. Hopefully I'm not too rusty with Python syntax. Okay, so the union xy. So basically for the union, first we call find to get the top level parent. So x equals self find x, find y. So if they're the same, we could just return a Boolean value to let us know if we connected. So if x is y, that means they're in the same component. So we don't need to do anything. We can just return false and say this failed. Otherwise, the way this works is you basically connect the smaller component to the bigger one because that makes the paths shorter. So if self ranks x is less than self ranks y, then you make y the top level parent. X equals y. Return, then else ranks. Or I guess, yeah, it was fine. So self ranks x is bigger. Then you make it the other way. And if there's a tie, you just pick one and then you increase the rank of that one. So we can just say make it x self roots y equals x and self ranks x. Okay, and we just return true, meaning this was successful.
Mm-hmm.
Right. So that's that. And then we can just run our problem now. So this can be like find earliest. Yeah, I guess in Python probably want to use camel. So I think classes are still Pascal case. Yeah. So find earliest time. So this will be like logs. So first we want to sort the logs. Then we want to. Are we actually given, by the way? Yeah, I guess. So we're given logs, but do we know how many people we have total here? Are we given that in the
Yeah,
input?
it's given n. We're given n.
Okay, cool.
That's a parameter.
Nice. Okay, great. So n is 0 to n minus 1, right?
Yeah.
Like okay. Yeah, so that's what you want in union find because it's basically 0 to n minus 1. So you just use union find. Whoops. N. And then you do. Yeah, so you just go through the logs. So for timestamp xy in logs, we can keep track of connections here, I guess. So we can do a connect. So we can do if union find union. If this was successful, that means we have another connection. And if the connections equals n minus 1, that means everything's connected. So we just return timestamp. Timestamp. Otherwise, if we never get it, then we just return -1 here. Yeah, and I think that's it. So
Okay,
do you want to try it
union
on this
find
one?
n. Connections equals 0.
Yeah, so union find prevents cycles, and it basically turns everything into a tree. And so in a tree with n nodes, you have n minus 1 edges. So if you have n minus 1 edges, that means everything's fully connected.
Okay, let me grab the question. Where's this question?
Okay.
Let's run it on some of those cases.
Okay, yeah, sure. So we can say print find earliest time. Let's take this logs here and do it. Logs n. Okay, let's see if we get an error. Okay, so it's 2019 031.
Okay,
Is that correct?
I'm gonna run this code in my
LeetCode?
yeah. It's a premium question, so I'm just doing it on the side.
Okay, got it. Oh yeah, you don't want to share premium questions, so they ask you like take down the video.
I've never had that happen yet, but
Not worth risking.
not for LeetCode. It feels like it feels those other guys.
Yeah. Well, I think those other guys, I like. Yeah, I don't know. They're also kind of smaller. Like LeetCode, I don't think they care because it's like massive. Like if you show a premium question on stream,
Yeah, everyone has
they're
it.
not gonna care.
Tests have went green. Holy crap, we're getting through these.
Yeah, I gotta slow down, dude. Otherwise,
No,
I'm gonna get
it's good.
too hard of a question. I'll get stumped.
Let me see. Let me come up with one more question. We still have time.
Okay.
Like it's easy to make it work too, but some people mess up the ranking part. Well, like for me, sometimes I accidentally put like the rank. I accidentally put like roots or something like this.
Oh yeah, I got
And
it.
that's
Yeah.
like just by accident, because you just have to really carefully look at these.
Yeah, yeah.
And then even this part, for example, you're saving the root. This part is very important. This is like how it compresses it, where you do root x equals that guy.
I mean, to be fair, like in an interview, even if you didn't do the compression, I think people would maybe say it's okay. I don't know. Like you're never gonna test it on like a million entries. You know, they're
Yeah.
not gonna put it in their LeetCode and test it or something. So.
But that's the part I would look out for if somebody is compressing it or is using. Otherwise, I mean, it's fine. It's a very niche algorithm.
Yeah, I think the compression makes everything run in like O1 amortized, which is like the benefit there. So.
Okay, let me get this. Okay, let me find you a question.
Okay.
That I at least have somewhat.
Yeah, you can't be giving me stuff you don't know how to solve. That's cheating.
Bro, there's nothing I can solve that you can't solve.
I mean, I don't know. I think I struggle on some stuff. Like that emails one was like not super, especially when you said like I think the way I struggle for something is if I say like I'm gonna do it this way, and you're like, yeah, I know you can do it this way, but like try this other weird way that you
Yeah.
would never do it, then I think that makes it harder for sure.
Yeah, only reason I said it that time was because you said that you wanted to look up union fine. So I was like, I don't know if we want to look up
Oh yeah.
anything.
No, I don't think I needed to.
But now
Yeah.
you have it at the back of your
Yeah. Yeah.
finger.
Yeah.
All right, video's going.
How much time have we done so far?
Dude,
Kind of
like
curious.
you're doing less than 15 per question.
Okay.
So you're given a string S and an integer K. How many questions start like this? You can choose
Like every
one.
single one.
Yeah, you can choose one of the first K letters of S and append it at the end of the string. Return the lexicographically smallest string you could have after applying the mentioned step any number of times.
Choose one of the first K letters of S. Okay. And append it to the end. Oh, so you're removing it from the front?
Well, K is one, right? So the range is you could only if K is here. You can only take anything from the first K, which is you could pretty much only take the first character and move it to the end. So you get you get C, and then you throw B to the back.
Oh, I see. Okay. Yeah, maybe this one's not so simple. Okay, so the first K. Okay, so you can either. Let me just make sure I get it correctly. Maybe overcomplicate. Yeah, I also have a tendency of like misreading the problem and then massively overcomplicating and then
What I'll
realize.
say is this one is actually a little bit harder than the other one. So if you think it's hard, or if you come up with an easy solution, we'll have to think about it a little bit.
Sure. All right, so you're given a string. You can choose one of the first K letters and append it to the end. Turn lexicographically. Okay, so the first move, we take the character B. Okay, so the one thing I noticed is, like, yeah, we can remove from the first K. Okay, so let's just go to example 2 because I feel like that's a little bit better. So in the beginning, we can only choose the B or the A, right? And move it to the end. So they chose to move the B. And then, okay, so they chose to move the B. So let's just do this like step by step. So in the beginning you have this. So they chose to move the B, which makes sense.
Mm-hmm.
Then, yeah, there definitely might be like a lot of edge cases here. Okay, so then they have this. So now, can I pick from the first again? Like, does that first change? I guess it does, right? Like,
It does change, yeah. You can.
okay.
It changes what you can do.
Okay, and I can do this as many number of times. Okay, I got it. So in that case, I would want to do it because I can move a C to the back. So I guess then I have AC. So it's basically just like, do I want to do it or not? And then at a certain point, I'm guessing you want to stop doing it. Okay, so now again, we can, yeah, okay. So now we again want to move the C. So now we have A, B, C, C. And now if we move the B, that's not good for us. Okay. Okay. Now the other thing I'm wondering is like, how many characters would we have to
The constraints.
no, not the constraints, but like imagine we can move every character. Can we always make it in lexicographically like best order? Probably. Like no matter what way it's in. So I'm just trying to think of like if I have some random thing like, this. Is there always a way to make this just completely, I guess let's keep it simple in terms of like A, B, C, D, E. So if you're like this, is there always a way, like in KS5 here, is there always a way to make it just completely like the graphically good?
Well, if you
And
can
I
pick
want to
from
say
anything,
yes. Huh?
Yeah.
Yeah, I want to say
Because
yes,
you
right?
can pick the smallest one, or you can pick like
The
the
biggest one.
biggest
Or
one. Or go ahead.
yeah, I probably wouldn't want to. Actually, yeah. So I'd want to pick the B here. I mean, there might be like some efficient way, but I'd want to pick the B here. So it'd be like D, C, A, B, and then next I'd move the C. Next I'd move. Okay, so if K is the length of the string, then there's always a way to make it completely in order. And
What about if it's less?
right. So what if like K is 3? Like, what's the best thing to do here? Or even 4? Like, now can we make it the best? So is there like some best operation to pick? So we definitely would want to take a character and move it to the back, but what's the best one to pick? I'm thinking. So, like, would we want to move the B this time, or that something else? Like, I think moving the B actually, like, if we move the B, because ideally we want to get ABC that. So if we do this, then we can then take the C, and then we can do, then we can take the D, and so on. Yeah. So here, so like for example, 4 is still small enough to make this whole thing like completely in order. Okay.
Mm-hmm.
What if we had 3, or like, yeah, what if we had 3? So then we like, would taking the B still be good? Think so. Yeah, because yeah. So in that case, we'd still do the same thing. What if we had 2? Yeah. So in case of 2, we might not want to do that because we can, like, we might not be able to access everything. Let's see. So here, um, yeah, if we have 2, like, which one do we pick? Do we pick the B or the D? So let's say we pick the B. So then we get D E C A B. Um, and then we'd pick the D, or actually A B C D. Yeah. So then we pick the D, I think. So this would be go here. Then we pick the E. Yeah, and I don't think we can make it completely in order now, right? Unless I miss something. Like, there's no way. I don't think.
What would you choose here, C or A?
Yeah, so then I'd pick the C. And I
Okay.
think this is the best we
What would you
can
choose
make.
here?
Then you just wouldn't choose anything.
Or go back? Go back.
Yeah.
What if you just chose A?
Okay, so if I chose A, then we get C, B, D, E, A, which would be worse, right?
What if you chose B?
Oh, we can't, because K is only 2.
You could choose B right there. B is the second element there. Or no, choose B next. No, in this next one.
Oh, choose B next? Oh, I see. Okay, so C, D, E, A, B. Oh yeah, so we are able to actually get it completely in order again. Huh. So that's what I was thinking. Like, if is it always just like, if K is 2 or more, we can always get it like the best? Like, can we turn any string and make it completely sorted? That might be like a trick question, I guess.
Like,
It
what's
looks
the
like this one we actually can.
this one we
Or go
can?
ahead.
Like, what? How would you? Okay, what would we do now? Like, how are we gonna get this in the order?
Yeah, so we can move the C next. So that would give us and that would be kind of simple if there's like a trick where you can always make it in order. If yeah, so this would be like this, and then we'd move the A, B, C, D next, and then the E, right? So it would be, yeah, A, B, C. We'd move the D next, and then we'd move the E, and then we'd get it in complete order.
Mm-hmm.
So I don't know if that's the case. Like, can we turn any string uh into the right thing by
And
just
what
doing
would be
this
a
enough
counter
times?
example?
Right. So I guess that comes down to the problem is like, is there a counterexample where we can't do this? So let's say KS2 again. And if we can prove that there is no counterexample, then the answer is always just a sorted string. So let's say we have like the same example of like let's just take some random letters. So like G, I, A. Yeah, I don't know like exactly what would be a counter. That's where you would just do like the leak code test cases to kind of like cheat your way out of it. Let's actually do numbers instead, like 1 through 9,
Yeah,
make
I
it
think
easy.
let's just think about it. I think what you said makes sense. Is pretend I have two at least, right? Then I'll just maintain. As soon as things the lowest comes into my window, I'll shoot it to the back. But like if we can perform that process always, I don't see a counterexample.
Yeah, actually, yeah. Thinking about it, yeah. So no matter what we have, right? Let's say we have numbers. We can always just keep moving things until 1 is here, and then we just keep moving everything else. So we can rotate everything else until our numbers and yeah. So thinking about it that way does make sense. So like, what we can do is essentially we can rotate this part. Like we can always just take the second guy and keep moving it until the second number is in. Well,
Or it's the
not in
reverse,
this.
right? Like you
Yeah,
just
yeah. It'd have to be some other thing. So if this was this, we wouldn't want the first two numbers to be in place here. We'd actually want to have yeah, we like I'm not like yeah, so it's not as simple as I thought. Like you don't want to just have the first guy in place and the second guy in place and so on. Maybe do you want like the last guy in place?
let's see. Where were you? Okay, pretend we had the one, right? We find the one. We shoot the one to the back. So
Okay.
now when do we? Okay, now we see the two. That's the second lowest. We shoot the two to the back. Okay,
Okay.
now what do we do? Who do we want next after the two?
So we want the 3.
So then the question becomes: is it possible to get the three after the two?
Is it
In
possible to get
any
the 3
case,
after the 2?
yeah.
Right.
Like, is there ever a case where we can't do that? And if we could always do that, then I think we'll do
Yeah,
it.
I'm trying to think. So yeah, I mean, I guess you can in some yeah, so basically you would yeah, I guess what you would do is you would rotate everything else, and then once you get to the 3, you would like move the one, and yeah, I guess you could. It's just like not super easy to see the exact
Yeah,
order, but yeah, I think that does make sense that it
yeah.
is possible. Okay,
Okay, okay. That would be k equals to two. Anything k
right,
over to two. What about if k equals to one?
right. So if k is 1, so that's our problem, right? So if k is anything bigger than 1, it's just always sorted completely. Okay. Um, yeah. So if k is 1, what would we want to do? So if k is 1, I think what we want to do is we can only we have to maintain exact order here, right? So if we have this case, we can never really move things in another order. We're kind of doing like a queue, and we're just like looping and looping.
Yeah.
And in that case, we would just find the smallest character, and that would be the answer. So in this case, we would just have the smallest one at the front, and then everything else would be behind it, right?
Smallest one, yeah. Smallest one at the front and everything behind it. What if there's multiple smallest ones?
Oh, that's a good
Yeah.
point. God damn it. Okay. So yeah, I didn't think of that. So like duplicates. Okay. So what if there's multiple smallest ones? Okay. Well, I guess one way to do it, not sure if it's the best, would be try all combinations and then just like store the best, right? So that would be n squared for k equals 1 because you have to like build the string over and over and over, right?
What does that mean? Like try to place one
Yeah, yeah. So
here
what I
and
mean
then.
is like we'll take this string, we'll store it as a result. Then we'll move the 9 and then we'll just do a string compare on this to our other one. And we'll store the best. Then we'll move the 8, and we'll just do this over and over and over, and then we'll just keep doing string compares. So essentially, we're just kind of like looping. We loop n times to get like every combination, and we just take the smallest one. So for every single one, we have to like build a new string, and we have to do a string compare.
Let's
So
work on a
that
simple example. This one's getting too large.
sure. Okay,
So
so
yeah, go
basically,
ahead.
what we do here is we'd say like, this is our current best.
Yeah.
Okay. Now we are gonna move the b to the end, and we're gonna compare that to that. Is that better? This is better. So this is now our current best. And then we're gonna do it again. So, uh, so, oh, whoops. So CC ABA, is that better? No. So we're gonna keep the old one. CABAC, is that better? No. And then ABACC, is that better? Yes. So now
So
this is
just
our
keep
best.
rotating.
Yeah, so we just keep rotating and we just compare, and then after that we go back to original, so then we just stop. Yeah, so that's our answer. Essentially, we just keep rotating. There might be like a way to better pick like the best thing in some more clever way, but definitely n squared would work. Are we looking for like better than n squared?
No, n squared is fine here.
Okay.
That would be n
Yeah.
squared.
Yeah,
Yeah,
because we're
because
rebuilding the string
yeah,
every time, right? So
yeah,
yeah. So do you want to go with that
yeah.
approach?
Let's go with that approach.
Okay. So def find smallest.
Finally, a good one.
Yeah, I feel like with this one it's just kind of hard to realize that with k being more than like 2 or bigger. At least that was like, yeah, maybe I need a little bit of guidance, but it was like at least I kind of went in the right direction, because I feel like if you don't think of that, then you're gonna get some really complicated stuff, right?
Honestly, I didn't know the answer either, so I was just like, I didn't give you really guidance. I was more like,
Fair.
I was like, oh, that sounds like an
like
interesting
like like
concept.
that's
Let's try
like
it.
that one what I would honestly do in leak code is I'd just code that, because I'd be like, maybe there's a counterexample but I don't see it and it's kind of hard, uh and then if it gave me an error, I'd do something else.
Yeah.
So maybe it's not the best, but yeah. Okay. Okay, so we have s and k. Okay, so essentially we have to do so if k is greater than 1, oh by the way, if k is, can k be 0?
No, k can't be 0.
Okay, so if k is greater than 1, then we do s equals s split. Or I think we just do list. Just do sorted, list, that, join. Okay, there's that. Now the other case is we're basically just comparing. So we're going to say res equals s. And then what we need to do is we need to, yeah, just go through the entire like string and try to do joins and stuff. I guess that's fine. I don't think it matters too much like how you do it, because you're gonna have to use a substring and add them anyway. So we'll just, okay. So we'll say for I in range length s. So essentially we'll say this is the, I'm trying to think of like how we'd want to do it. So if we have like this ABC thing, I mean, I guess we can always just make it a queue and just loop around as well. It might be easier. So yeah, we can just say like q equals dec, and then that, and then for car in s q append car. All right, and essentially we're just gonna loop through this, like whatever, for this in range length s. So we're gonna just take the first character and move it to the back. So q append q pop left. Okay, and then we'll say cur equals join q. And then if cur is less than result, I think that'll work. Yeah, so essentially we're just always doing the same thing and then just return result here. Okay, so do you want to try it on these examples?
This question on these examples, yeah. Let me just write it. Let me just run it in the code. Pretty sure you're good.
Okay.
Submit. Perfect.
Okay,
Yeah,
nice.
it's a hard one. That one's like hard.
I feel
Like this,
like just coming up with the intuition is kind of hard.
it
But
is.
I don't know if there's a linear time also. Maybe.
No, like the solution is your solution.
That was my solution.
Yeah.
Okay. Okay, yeah, and I will say I haven't done this one before, so
Nice.
or at least if I have, I don't remember it at all. So that's kind of cool.
Cool. Thanks, Alpha. Thanks for hopping on. Good
Yeah,
luck with
no
all your
problem.
stuff. We'll do this again. We need to like
Okay.
do more system design ones too. I
Yeah, we
think
could do more of those.
what I'm gonna do is I'm gonna do a long stream where I just ask people system design questions. So I could
Yeah, I
get
feel like
more.
that'd be good because you have so much coding stuff. I think
Yeah.
it also kind of would show me like where I am in system design relative to other people because no one does system design
No
on
one
here.
wants to hop onto the system design. Only you're the only one who's like asking me to
People
do
only
system
want to
design.
get interviewed and stuff they're good at, you know.
Yeah, they don't want to see.
It's all good though. Happy to fail on stream, you know.
Yeah. All right. Thanks, Alpha.
Yeah, see
See
ya.
you around. Peace.